Hi, this video goes through the key things that you need to know ready for paper 2. First up, we've got computational thinking. We need to know about decomposition, breaking a problem down into smaller parts so that it's easier to solve. Abstraction, where we focus on just the important details and remove or ignore any irrelevant information. And algorithmic thinking, identifying the steps needed to solve a problem. Structure diagrams look like this. You have the name of the system at the top, so I've got a sat nav here, and then it breaks down or decomposes that system into the different parts and what they do. So you can see that we go down the input destination section, and off of there we can either choose a new destination or go with a saved destination. If we're looking down the outputting directions section of the program, it's got the map or it's got the list as the way of presenting that. Trace tables help us identify logic errors. So I've got some code on the left, and then on the right I've got a blank trace table. A trace table will let you keep track of what each variable is, what the value of it is as the program runs, as well as any outputs. So as we look at the code on the left, on line 1, x is equal to 5, so my trace table, I pop that in. On line 2, y is equal to 0, so I put that in my trace table. Then we go into the loop, and on line 4, y is going to equal y plus 1. So at the moment, we know that y is 0. So when we add 1, it becomes 1, which I've put in there. Then for line 5, we're doing x minus y, which is going to be the new value for x. So we can start to add in all of the values on our trace table. I'm not going to go through it all now, but if you need to, you can pause the video and work through it in your head. Flowcharts, we need to know which symbols are used for which things. So on the board, we've got the different flowchart symbols that you need to know. Most of them you'll be pretty familiar with. The trickier one is the sub-program, so we see that slightly less. I'll give you an example. So here we've got a lighthouse, and on the left we have got the main code. So that's the main code for the lighthouse. You'll see that down the bottom it's currently highlighted blue. The sub-flash is a subroutine that's going to run. So when we get to that point in our main program, it's going to run the sub-flash subroutine or procedure on the other side. So then that takes us to our new flowchart, which you can see is on the right, and that's the flowchart that shows the subroutine. For searching algorithms, we need to know about a linear search and a binary search. We're going to start with linear, so it starts with the first item in the list, and then it checks each item in order. It's slow when there's a lot of data, but it's quite simple to program. A binary search finds the midpoint. It checks if that's a match for what we're looking for. And if it isn't, then it removes the half of the list, including the midpoint, that will not contain the item. And then it finds the new midpoint and repeats again. This will only work on a sorted list, and it is faster than a linear search. For sorting algorithms, we'll start with bubble sort, which compares the first two items and then swaps them if required. So if they're not in order, it would swap them. It then compares the next two items and repeats. It's slow when there's lots of data to get through, but it's easy to program. Insertion sort. The first item becomes the sorted list, and the rest is the unsorted list. And then each item from the unsorted list is inserted one by one into its correct place in the sorted list. It's slower than a merge sort, but it's faster than a bubble sort. And then finally, a merge sort splits the list into individual items. So it does that by halving the list and halving it again until they are broken down into individual items. Sometimes in the exam question, they'll tell you that that's already been done for you. If they don't mention it, then you need to show that step. And then it merges the items together in pairs, sorting them as they merge together. So as it joins a pair, if they were in the wrong order, they get swapped. And then it merges the new list into pairs again and repeats. It's complex to program, but it sorts large lists quickly. We've got a whole load of operators here that you need to know. Most of them are fairly straightforward and ones that you're used to using frequently. We've got mod and div. We know that mod, after a division's taken place, gives us the remainder, useful for if we're breaking things down into wanting to know pounds and pence or hours and minutes. And then div is the other part of that. So after a division, it gives us the whole number, the quotient. The programming constructs, we've got sequence, where instructions happen one after another. Selection, which will usually be our if and else, although can sometimes be switch case. And the program can take different paths. And then iteration, which we know is our loops or our repetition. We've got a few programming terms that we need to make sure we're familiar with. A variable is a named memory location that holds a value which may change. A constant is a named memory location that holds a value that does not change. The assignment is the value that's assigned to the variable. So if you had age equals 3, then 3 would be the assignment. The identifier is the name of the variable. So in the example I just gave, age would be the identifier. Quick reminder on how to generate a random number. We have our variable, we have the random.randint to generate a random integer, and then in brackets we put our range. So I want that to be from 1 to 10 in this example. In terms of our loops, which we mentioned just now, we've got the two types, count controlled loops, which will be for loops, and they repeat a set number of times. They're really useful for if you know how many times you need something to repeat. A condition controlled loop is a while loop, or sometimes a do until loop, and it will repeat while a condition is met. They are used when you don't know how many times it's going to need to repeat, because that is dependent on another factor. Data types, we've got an integer, which is a whole number. So for example, 4. A real or a float, as it might be called in the exam, it could be called either. You can put either and you will still get the mark, is a decimal number, 3.2 as an example. String is text. Boolean is either true or false. A character is obviously a single character, may sometimes be referred to as char. And then casting is that term for changing between data types. They love a question on that. Make sure that you're able to say what casting means. String manipulation. So if I've got a variable name and I've got the name Matilda in that variable, the command name.length would give the value of 7, because that's how many characters we have. Name.substring 3, 4. 3 is our starting index. So remember that we always start with the first index being 0. So M would be in index 0, A would be in index 1, T would be in index 2, and I would be in index 3. And that's why our substring here, of splitting that bit of the text up, is going to start at I. And then the second number in the brackets is how many characters to take. So we're starting I in index 3 and we're taking 4 characters. So it would return Ilda. Name.left 3 you might see in the exam paper, and that would take the 3 characters from the left. So in this case, Matt. And name.right, and then in brackets 4 is telling us that we would take 4 characters from the right. Also, in terms of string manipulation, we need to be familiar with name.upper, which would return it in uppercase. Name.lower would return it in lowercase. I'll just jump back to that. I went too quickly. We might see this where we've got ASC for ASCII, and then in brackets, the letter A, for example, that would return the ASCII number for A. So in this case, 65. And CHR is the opposite. That you would put in the number to represent the ASCII character, and then it would return to you the actual character. File handling will look a bit like this in the exam. So we can have new file.sample.txt, for example. All of these are just examples. You could obviously have anything. That would create a new file called sample.txt. When we open a file, if there's a file that already exists and we open it, we want to open it into a variable. So in this case, I've called the variable my file, and it could be called whatever I wanted, but that's what I've gone with. And then the open command will then open the file in the brackets. So sample.txt is my file. At the end of any file handling, so no matter what the question is, if you had a file open, you have to close it, and that's always a mark. So if I've referred to it as the variable my file, then I'm going to have my file.close and my open and close brackets, and that will close the file. That's an easy mark. If you see anything on file handling, don't forget that one. We can read a line from the file using this command, and we can write lines to the file using the write line command. It might be worth having a pause of those on the screen and having a look through them. 1D arrays are basically lists, and in this case here, colours and then the squared brackets, which are what immediately tell us, oh, this is an array. We create an array called colours with space for 5 elements, and they would be indexed from 0, starting from 0. This here, colours, and then the name of the colours in the square bracket would create an array called colours with those 3 items in it. This line here would print whatever's in index 1 in our colours array. So in this case, green would be in index 1 because we start at 0. And then this would change whatever's in index 1 to yellow. So at the moment, index 1 is green, but it would change it to yellow. 2D arrays are lists within this. So in this case, we will have, for example, game board 6,6, which is going to create an array with 8 elements. And then if we've got on here a position, so for example, 1, 0 equals queen, then it would add queen to the position 1 in the array. Subroutines. We have to know the term subroutine, which is just a set of instructions that are designed to perform a frequently used operation in a program. And we've got within that procedures, which are where a section of code performs a specific task, or functions where a section of instructions, when they're called, will return a value to the main program. So a function and procedure are very similar. The big difference is that a function will return a value back to the main program. And then parameters are the variables that are fed into those subroutines. They don't always have them, but they often will in the exam. Example here then, so this one, we look and we can't see the word return, so we know therefore it's a procedure. And up here I've got the procedure name, so in Python we use the def command at the top. In the exam they will use proc for procedure, but we write in Python. In brackets are any parameters. If you have more than one, they're separated by commas, and this is the variable that's going to be used from the main code. All of that code there that I've got indented is inside my procedure. So it's indented to show it's inside the procedure, and you can see that it's going to just do some stuff. And then down here, we've got our main program or our main code. And in our main code, it's going to ask them for their name. And then it's this second line here that's going to actually run the code. So because it is a procedure, we can just call it by putting its name and bracket, and then inside the brackets goes whatever you're sending into the parameter. So the data that's being used. In this case, it's the name variable that's going in. Functions are similar to procedures, but they always return a value back to the main code. So if you see a function question and it hasn't got the word return in it yet, that's something you're going to be having to add. And if you see a bit of code and it's got the word return in it, you know straight away it's a function. They usually have parameters, variables that are fed into them, we just mentioned, and they use a variable to store the result of the function call. So when we go to call a function, we have to actually make a variable first so that whatever's coming out of it, whatever's being returned, has somewhere to be stored. And so an example here, I've got a function which I have called calculation, and my parameter is tickets. In this case, that's going to be coming in from the main program. The actual function code is indented, and you'll notice that we've got the return, and then it's returning the cost variable back into the main program. And then down the bottom, we've got our main program. So this runs first. The procedure or the function, in this case, will only run when it's called. So in this case, it's going to ask how many tickets they want. And then it's going to actually call the function. And calling a function, it has to call it into a variable. So I've got the variable as payment here. You can call it whatever you want, but just don't call the same as other things. And then it calls the function by calling its name, the same as you would with a procedure. We're just doing it into a variable. And then again, in brackets, we show what's being fed into it, into the parameters. Once we have run a function like this, whatever's been returned could then be printed if you wanted to, which is why my last line down there is print payment. Defensive design is all about creating a program in a way that is minimizing the misuse or things that could go wrong with it. And so the term anticipating misuse is where we're planning for all possibility. We're predicting what people might do wrong, either intentionally or by accident, and preparing for it or trying to prevent it. As part of defensive design, we can use authentication, which is verifying the identity of a user, and that can be done through usernames and passwords or other methods. Validation is when we check the inputs meet the criteria. So when we're asking someone to type something into our program, we want to make sure that what they're typing in is sensible and could actually work. We're not checking if it's true. So if we ask them for their name and they type in a name that's wrong, we're not going to be able to check if that's true or not, but what we can do is check if it is sensible and fits the rules. So we can check if that name is the number of characters we would expect. We wouldn't expect someone's name to be 200 characters. And then maintainability is also a part of defensive design, and that's making sure that your program can be easily maintained and updated by future programmers. And as a quick reminder on that, programs should be written in a way that means that they can be easily updated or understood by other programmers or yourself in the future. This can be done by using subprograms, naming conventions, indentation, or comments and comments. All of those can help. I'm going to quickly go through how they can help. So subprograms, we've just mentioned, are the name section of a program that performs a specific task, and it can be reused whenever it's needed. It can be a function or procedure, and we've already mentioned what they are, so I won't go through that now. The reason that subprograms help is that they break a program into smaller, manageable chunks, which means you're less likely to make mistakes, but they can be reused and called multiple times without rewriting code. So in terms of maintainability, if someone's going to update a program, they're only having to update it in that one section of the subprogram, not all the places where you've repeated it if you hadn't used them. So it makes the code easier to test, debug, and maintain. Naming conventions are the rules and guidelines that we use for naming variables, constants, and subprograms. So basically sensible variable names, so using cost rather than C, so that a future programmer can look at it and be, oh yeah, that holds the cost, rather than what on earth is C. Consistency of the format, so if you're using underscores or capital letters, sticking to that same format for your variables so that it keeps it nice and clear. Indentation is the use of tabs to show the structure of a program, so showing what code is inside the loop. We know that in Python we have to put that in, and it clearly shows what code is going to be inside either the if and else, or as I say, the loops as well, or subprograms. And it improves readability. Comments also help with maintainability. They let us explain what different sections of our code do to other programmers. They're ignored by the computer, they don't run, but it means that a future programmer could look at my code and see that, this is what this part does, or you could use a comment to identify a section of the code that's not working for someone else to look at it. And so I've put there, improves readability, it explains any logic of why you've done certain bits of code, and it also supports working with other programmers, so other people. It's kind of a way of communicating within your code. Testing allows us to identify errors, but most importantly, so we can fix them. If it asks you why we test our program and it's a 2-mark question, don't just put to identify errors. Why do we do that? It's so that we can then fix them. And we've got iterative testing, which is done during development. So it happens multiple times. You might create a bit of your program, test it, create some more, test it. Happens throughout or during development. And then we've got final testing, which happens after development. So you finish creating your program, you get your list of success criteria, and you would go through and check it against them. When we do test, we use test data, often to fill out a testing table. So we want to test things that should work and should be accepted, like normal data. We want to test things that are right on the edge of what should be accepted. So if we wanted to allow people to enter an age up to and including 100, then 100 would be an example of boundary data, because I want it to accept that and I need to check that it does. And then invalid or erroneous data that should not be accepted by our program, and we would expect to see an error message, because we also want to check that if someone shouldn't be able to type in 150 as their age, that it doesn't allow that. Errors, we've got a syntax error, which is a grammatical error, so it breaks the rules of the programming language and it will stop the program running. Whereas a logic error, the program doesn't stop running, the code will work, but it will do something unexpected. And logic errors are often to do with operators, so maybe you've used the less than symbol when you meant to use greater than. Maybe you've got your if and else, but you put your outcomes the wrong way round. Those sort of things would be logic errors. And we know from earlier on that logic errors can be spotted using a trace table. In terms of programming languages, we need to know about high-level languages, so things like Python and Java. And that's where the source code is easy for humans to write. It's much easier for us to write in things like Python than it is to write in binary. The downside is it needs to be translated into machine code for the CPU to run it. Low-level languages, we're talking about machine code, binary, also assembly language, and it allows the programmer to control exactly what the CPU does. It gives that level of control that you wouldn't get with a high-level language, but it's difficult to read and modify. As humans, we find it hard to write in low-level language, which is why we don't go around writing in binary by choice. And it's usually specific to a machine or processor. So it's what we call, it's not portable. So it can't be used on one or created for one computer and then applied to another directly. It will often have to be machine specific. That leads us on to translators. They're used to convert high-level language into binary or machine code. And we can have either a compiler or an interpreter. Compilers convert the whole code into binary at once. They create an executable file. They won't run with any errors. And they're slow to compile, but fast to execute. An interpreter converts the code into binary one line at a time. It runs until it reaches an error, and then it will stop and say that you've got an error. It's slower to execute than compiled code, because every time you run it, it's having to translate it line by line, whereas with a compiler, you're translating your whole code and then you've got your executable file ready to run. IDEs, we've got different parts that we have to know about. So whenever we see a question about an IDE, just think about using Python. It's that environment, basically that app we use to create our code. And so we've got editors, which is where we write our code. We've got the runtime environment, which is where our code is run and tested. So for us in Python, it's the Python shell. Error diagnostics, where we're identifying errors and spotting them by using that tool. Translators, which we've just mentioned, we know convert high-level language to machine code. Color coding commands, which makes it easier to read and have a look at where the different parts of your code are and your code structure. Automatic indents save us time when writing loops. And then we've got logic gates. So we've got this one, which is our NOT gate, and we know that whatever goes in, the opposite comes out. Underneath it, I've put the truth table. So it shows what the outcome would be depending on the input. So if the input is if it is 0, it's going to give us a 1 coming out, and so on. Then we've got an OR gate, which will allow a 1 to come out as long as at least one, so including both of the inputs, are 1. So if A was a 1, we'd get a 1 come out. If B was a 1, we'd get a 1 come out. If they were both a 1, we'd get a 1 come out. The only time we're not getting a 1 come out is if both of them are 0. And an AND gate, and in terms of drawing it, looks like a capital D, so that can sometimes help remember which one's the AND gate. And with an AND gate, the only way we get a 1 coming out is if A and B, so both the inputs, are a 1. So any other combination, like 0, 0, will give us a 0 coming out. A could be 0, B could be 1, but we'll still get a 0 coming out. The only time we get a 1 coming out is if they are both a 1. And we can draw logic gates combined together. So just as a tip on this, when drawing the gates for an expression, draw the brackets part first. So I've got 3 examples here. So the top one is not A or B. If we did the A or B bit in an OR gate first, then we can use a NOT gate to show that. And then the same with the second one, we've got not A or not B. So I would do a NOT gate with A, I'd do a NOT gate with B, and then I would have both of the outputs of those going into an OR gate. So do the bracket part first, and that will help you a lot. Databases, we need to know a couple of terms. So fields are basically our column headings. So in this case, we have the contact name, and that will be a field. And so that will hold all of the data for the contact names. A record is like the row, it's all of the information about one item in the database. So in this case, it's about a contact, and it's all of his information would be the record. Databases will mostly come up with some SQL questions. We know that SQL is that language used to write databases. And so you'll get a question a bit like this, where you're given the name of the table. They will always tell you the name of the table, and you'll get some data, and then it will ask you usually to write an SQL statement. We know that when we write an SQL, we always follow that rule of select is our first command, and then we put the field name. If it's just one field name like this, we would put select item code. If it was multiple, we would separate them with commas, never the word and, always commas. From is the easiest mark ever. It's the name of the table. So from, and then the name of the table, which they will have given you. Just make sure you spell it the same. And then where is the trickier bit. It's our criteria, but they will tell us what we're looking for. So in this case, we want to show where there are less than 10 in stock. So I've put the field name stock and then the less than 10. And where can have multiple things. So we could have a where stock is less than 10 and item code is equal to A1 or something like that. The only other thing that we need to know is if we are wanting to select everything, all of the fields, we can use select star, and that will select everything. So if it says to select all or select everything, we can do select star. From results, this is what this table was called. And in this case, it was where subject is equal to art. If it's the string, so if it's text, it must go in speech marks. If it's a number, it doesn't have to. And then some tips on writing the big algorithm questions. So when you get one of those algorithm questions, it's worth a lot of marks. Firstly, always just write it in Python. That's what you've been trained to do. Break down the question. So underline the key parts, work out the different things that are happening. What are the inputs? What are the outputs? Is there a loop? What kind of loop is it going to be? Is there some selection? And then start to plan the snippets of code before writing your whole algorithm. So annotate around the question, label how you're going to write out the inputs, label how you're going to write out the loop. And by the time you've done all of that, you've got all of the parts that you need to be able to write your whole algorithm, and you can just join them together like a jigsaw and write it all out neatly underneath, and you are done. And most importantly, always try. Remember that those algorithm questions, the only people that are getting 100% of those marks are grade 9 students. And so actually, you're going to be aiming for as many marks as you need, but you won't get those if you leave it blank. So have a go, get the marks for all the bits that you know, try the bits you don't know. Remember that they sometimes will give you marks for things like an attempt at selection. So even if you've tried to use if and else, but you've done it a bit wrong, you still might get the mark. The same with loops and things like that. So always try, always write something, never leave it blank. And good luck.